Oh my, goto statements, they lead to spaghetti code. In the past, we didn't have while loops, if statements, and programmers used goto to make up the logic of their programs. It was a mess. That's why the computer science gods created methods and conditionals and loops. Structured programming was a revolution at the time. But what if I told you a goto statement can be very appropriate in a few places? Let's talk about it. And we're back. First thing I want to show you is some assembly code, stuff that I used to do at the beginning of my career, TIDSP, and go through how in assembly code, it is loaded with goto instructions. They call them branch instructions. So in this particular case, we start out with, we do some preparation and we get down to our process loop, and then we're using the AR5 register as kind of a way to pass arguments back and forth, for example. It's going to do the compare register instruction, CMPR, and it's going to look for a -1, which is an error condition, all Fs. If that passes, that branch instruction will jump to the error handler. So it's really a goto instruction with some conditions on it. It's kind of like an if-else. Now, where it gets more interesting is when you get to the end of the loop, it just branches right back to the beginning. No qualifications, no conditions. It's a goto statement. So any type of looping that you ever had to do in assembly or any, some kind of combinational logic, you're always going to have this branch unconditionally statement somewhere. You have to do it. You'd never be able to get any coding done without it. Then along came C, and they wanted to make a portable assembly language. So they had to have a branch instruction unconditionally, and that is your goto statement. But there are other jump statements in C that are like the goto statement, maybe with some conditions on them. One of them is the break statement, which we use in our switch case logic blocks. We have the continue statement, which you can do in loops, which means just go to the end and then continue the loop. Obviously, you have the goto statement and you have a label, which is the one that our computer science cousins absolutely forbid us to ever use. And you have the return statement, which is really leaving the function that you were calling from and you're getting out. I'll talk more about that later. There is some concern with that. So let's take a look at what C does when it compiles and generates assembly code for us. So I did an example with a simple while loop, and it's going to use a count variable, and when it gets down to 0, the loop is going to end, okay? Now, for what this looks like in assembly, and in this example, I did it in ARM. It's going to initialize the count. It's going to move a 5 into register 0. Again, on ARM, the first R0 through R31, those are your general purpose registers. And then we're going to have a label for our while loop. The first thing it does, it compares to see if R0 is 0. And it's done with an immediate #0 argument. Now, if it's less than equal, we exit the loop. So just like in the TI assembly, we have a goto statement with some conditions on it, or basically it's an if statement. Now, likewise, we still need to branch to the beginning of the loop again, and there you go. You got your branch unconditional right there. Branch and the name of the label. And if you're not familiar with assembly, the label just takes place of you having to remember the specific address of the instruction you want to jump to. So really in C, the goto label, that's the command that we're going to be talking about. The other jump instructions, those don't have the curse on it. The goto statement is the one that's cursed that you can never use. And for a long time, I believed that as well, because I was an engineer, I had computer science colleagues, and I would read, never use goto statements, they are bad. Then later on, as I developed and got more fluent in C, I realized there are places where you can use goto, and it's very, very helpful. The funny thing is, I did some research on this. There have been white papers on having structured programming with goto statements and how you can leverage that to make your code more readable. If you get a chance to look up the Donnelly Knuth, I think I pronounced that right, Knuth paper. And if you look at this example here on the left, you have multiple nested if statements, and then you're going to go to different error conditions. But if you do look at it on the right with the goto statements, which one would you rather see? The one on the right is cleaner, easier to understand. And I want to show some examples in the coding, the real-time coding section next, where if you're trying to develop a driver or you have a nested loop, for example, and you need to get out of that nested loop, the goto statement is the way to go. All right, let's do a quick recap. Number one is spaghetti code. If we did everything with goto statements, it would be very hard to track for the next guy that comes along and looks at your code. If you're jumping here, jumping there, you can get quite messy quickly, which is why they invented C. One of the reasons why they invented C. Not only does it make debugging harder, you know, you're jumping across different sections of code and possibly different modules. And then you can't even track how variables were modified anymore, or why you even did the jump in the first place. So one of the benefits of C is you can do everything without goto statements if you wanted to, because they offer you for loops, while loops, if, switch, and goto is going to bypass all that. You've already seen one use case with the error condition, and it's quite handy for that. Another reason you got to be careful with goto statements is if you're jumping around, let's say you're inside of a scope, especially in C++, you're inside of a scope, you've allocated some memory using RAII, let's say you instantiated a container. If you jump outside of that scope, you're not necessarily going to reclaim that memory. It could lead to memory leaks. Now, I don't know if the compiler is smart enough to catch that, and maybe we will test that in the next section. You know, and finally, there are alternative constructs for the goto statement, which we already know about. The break, you know, the break keyword, continue, return. There's almost no need to use goto. So we will reserve goto for the particular two use cases, nested loops and for error conditions. All right, so let me spin up Eclipse and try to put some code examples together, and I will be right back. Okay, and we're back. So for the first example I have a set of 3 nested loops without using goto statements, and I set up a 3-dimensional array using vectors, which you see right here, and with the constructor set up as such. At one of the locations in the center, we'll set it to 42 by hand right here. And as we rip through these containers, I made life easier by using range-based for loops, another advantage of C++, using the auto keyword so we don't have to worry about the type. The very inner loop, if we find that value, which should be at 1 right there, we will break. Now, however, that breaks us out of the innermost loop. We still have 2 more loops to break out of, so we have to check for found again and check for found again, and then we can break. So if I set a breakpoint in here, we hit the first break, we're going to hit the next conditional statement, we break out of that one, we break out of that one, and we're out, we returned true, which means we found it. That's simple build program. Now for the next example, I went ahead and put a goto statement in the center of the nested loops, and you can see we go from this with a lot of extra lines of code to something that's pretty clean and simple. Your conditions are set at the very end. It actually works quite nicely. Set the breakpoint here. Okay, I just learned something. You cannot put a breakpoint on a goto statement. I had put it here and it just blew right past it. So I was like, okay, something's wrong with this code. And I looked at it, I'm like, no, it's fine. So I went ahead and put the breakpoints here and here instead, and now it works. Show you. And it returns true, so it did find it. So conversely, if I were to change this value so it'll never find it, it should break here on false. And it does. So you get the point. You can make a nice streamlined search function for multi-dimensional arrays, have nested loops. And I know there's other algorithms for doing search, but let's say for simple things like this, we are just ripping through nested loops. It's quite a bit cleaner to just use a goto statement. For my next example on 3, I'm going to go over something you would see in drivers, and you're looking for error conditions when you're setting something up. It's just a generic example. So in this case, it's going to look for a file error, an input error, connection error, or any combination of those. And look at these conditional statements here. And I'll set a breakpoint and we'll just kind of go through it real quick as it runs. All right, we come to the first check and jumps through, and as you can see, I set the error condition right here, and it returns a error condition of 3. And if there were no errors, it would return 0. But you get the point. With a lot of conditional statements like this, it can get quite messy, and you probably could replace this with a switch or case statement also. Now for my last example, let's see what happens with goto statements. With this, we're going to jump to like a little sub-functions, not lambdas. We'll talk about that later. We jump through these little subsections here, and if there's any errors, we bump the error counter and, you know, print some stuff out so we know what happened. And now if we run this, okay, we stop here on the first error check. We step over, it's going to check the next stage, jump to the next stage, bump it again, and we're done. Turned an error code of 1. So anyway, you get the point. You can use your goto statements to clean up the kludgy code. Now, it's ironic that goto statements, we're told to avoid them, to avoid spaghetti code, and I agree with that 100%. There's these few corner cases which seem to pop up more than you realize, where a goto statement kind of like is a nice way out. And in my own projects and in my own development efforts that I do, even commercially, there's been a few times where I had to use a goto statement. And, you know, if you have a coding standard where you work that doesn't oppose that, that's not going to flag that as some kind of crazy thing, like you can't do that, well, then use it. I think for maybe every 10,000 lines of code I write, I might have one goto statement. It's just something to keep in the toolbox. Before I wrap up the video, one thing I wanted to try and to show everybody is, what if you did a goto to a label that is outside of your scope? Well, we go back to the first example. I put a goto found, which is a label, which would be down here in this function. As you can see, it's already throwing an error. I mean, yeah, it won't build. So it's good to know that. Now I'm going to try to see what happens if we jump out of scope inside of a function. I'm going to create my own scope, and that's easy to do. Just use brackets. And I want to jump out of this to found. And in here, we'll create a container, call it test. So test will be allocated on the heap. So if we jump to found, we leave this scope. What happens to what we allocated for test? Now, normally in normal progression, as we step through code, when we leave this block, test should return its memory back to the heap. All right, let's do a little test. I'm going to allocate some memory. I'm going to put this in a loop where we go in and out of this context. I'm going to watch the memory usage. All right, a little bit of a time warp there. I don't want to bore you with coding. All right, so I created a loop and I put scope inside the loop. We'll go in and out of this scope right here, which I artificially created just by using brackets. Instantiate a container with 1,000. In fact, let's make it exaggerated a little bit. And we're going to jump to bypass. And when it jumps out of that, this should be reclaimed. So we're really going to make the operating system work on this test. And okay, let's run it. Okay, I set the breakpoint at the very beginning, and let's let it run. Okay, so I've been letting this run for just a few minutes, and I've been watching the memory usage, and it doesn't look like it's growing. No, it's not. So RAII, when you're using a goto statement, when you jump out of context, your memory is reclaimed. But I will say, depending on the compiler that you use, if you're using Clang, this is GCC, your mileage may vary. Something to be aware of. So if you find yourself in a situation like this, where you're going to jump out and you have some kind of standard template library instantiation, just be aware that you may have a memory leak. I don't think you do. Probably this situation would never come up anyway, but you never know. Just something to be aware of. And I ran a test like this, and it seems to be fine. In fact, in order to get this to build, when I had, let me stop this. When I didn't have this here, it threw a warning. It wouldn't let me build. So it had something to do with this label being the same thing as the end of this loop here, and the compiler caught it. So anyway, I'm going to wrap it up. Just keep in mind for the goto statement and what you can do with it. There are certain situations where if the code's really messy and you just want to quickly get out of it, use your discretion and use it. I've used it here and there. I don't throw goto statements all over the place, but once in a while, there's just some weird combinational logic that I run into, and the goto statement is the best way to get out of it without creating a copy and paste situation with a ton of code and where it's quite messy. And I'll put a goto statement. I put a comment in there too, like, hey, I put this goto statement here on purpose. It's all good. So that's it. I'm going to wrap up this video for now, and I will see you on the next one. Take care.